Welcome back for the third video looking at the correlation between caffeine and sleep. So over here on the left, we have the work that we've already done. We've already summarized the data table, gotten all the sums, ends, and means. We drew the scatter plot, and then in the last video, we calculated the two variances, the covariance, and we got an R of negative 0.94. So in this video, we are going to evaluate the R. So remember, our null hypothesis, in general, your null hypothesis is always there's nothing going on. So the way that we word that in a correlation is there is no correlation. And for those of you that want to just do this with as few characters as possible, you could just say R equals 0. The alternative hypothesis says that there is something going on. So in this case, we word it, there is a correlation. And again, for those of you that want the shorthand version of this, it's R does not equal 0. So just like always, when we have an observed statistic, we have to look up the critical statistic. And in order to do that, we're going to need degrees of freedom. So for the correlation, the formula for degrees of freedom is simply n minus 2. So our n in this case is 5. So 5 minus 2 is 3. So you are going to look up your critical R on your critical R table. So I already have the critical R here, but I'm just going to show you, if you're using our book, that this is on table 3. If you're using our book, which is on page 257. Remember, what we're going to do is we're going to use the two-tailed test. We're going to use it at alpha equals 0.05. So you can see that with 3 degrees of freedom at alpha equals 0.05, the critical R is 0.878. All right, so here's the decision rule. And this is interesting about R because we could get a negative. We have to put this absolute value thing here. Remember, with absolute value, anything inside the absolute value sign is a positive. So for example, the absolute value of 6 is 6, and the absolute value of negative 6 is also 6. The absolute value just means the distance from 0. So if the absolute value of the observed R is greater than or equal to our critical R, we're going to reject our null hypothesis. Otherwise, we're going to fail to reject it. All right, so we're going to be comparing these two numbers. Our observed R, which we calculated, of negative 0.94, and our critical R of 0.878. And again, for the purpose of this, we're essentially going to ignore this negative sign. So is 0.94 greater than or less than 0.878? Well, it's greater than. So 0.94 is greater than 0.878. So the decision is going to be reject our null hypothesis. Now remember, the null hypothesis says there's no correlation. If we reject that, it means there is. So there is a correlation between caffeine and sleep, but we can be even more specific than that because we have a negative R. So we know that the correlation between caffeine and sleep is negative. So what that means is as the amount of caffeine increases, your sleep decreases. All right, and for journal format, we always start with the statistic, which is R. We put our degrees of freedom in parentheses, which is 3. We put an equal sign. After the equal sign, we put the value of our observed statistic, which is negative 0.94. And because we reject, that means it's P less than or equal to 0.05. All right, so that is it for correlation in 3 videos. When we come back in the next video, we're going to do regression.